In devising sense-based teaching and learning digital software, one thing to keep in mind is the computer cannot perceive the world as we are feeding into it. A digital world of software apps, AI, etc., knows only data, not experience. Hence, measure is divorced from the subject that is being measured. Much can be learned and gleaned from the process about how learning works. To gain a greater perspective on this concept, let us travel back 2.5 millennia, way back to the days of ancient Greece. For it was none other than Plato who first fathomed the question of what are numbers. His theory held that there exists a separate dimension, a domain of the heavens, apart from material man's purview, where numbers exist in quantitative form apart from material things to be measured. Hence, numeric systems live in independent entities governing the universe. The terms and concepts of Platonic mathematics greatly influenced mathematicians, philosophers, and physicians throughout the remainder of the ancient, medieval, and modern age. But this notion may serve a special utility in the age of growing digital media and AI. Traditionally, basic mathematics is usually taught in two general ways. Numeric rote, a typical example, a child is taught to count numbers and to look at numbers of things such as balls or pencils. And you could have a correlative measure of quantity. When placing numbers into software and presenting them in a lesson, the instructor must select what objects, images, and colors represent what is being measured. As a programmer and instructor assigning objects to be presented in correspondence, the clearer and more consistent the properties chosen, the more functional the software will present. We must always keep in mind that software itself does not know what corresponding images and objects fit with your lesson. You must delineate the form, function, and pattern of the core content to decipher the numeric models that can be fed into the software. Computers only know the measurement, not what is measured. Instructors who teach intermediate and advanced math already have a cultivated and built awareness of abstract number concepts. For topics such as algebra, geometry, and trigonometry, practices measured explore the hard quality of even unreal numbers. Such quantities cannot exist in a conventional concrete sense, though they may have proven vital in cutting-edge fields such as quantum physics. One way of understanding the boundaries of quantifiable real and unreal is the notion of infinity. We know that the unidimensional number line, infinity, comes in three forms: left, right, and center. Left being negative, right positive, and center representing the infinity, limitless fractions between them, between each integer. A somehow analogous component exists in language. Words, whether written or spoken, exist separate to the concrete objects, phenomenon they represent. Although there is one distinction the language enables would be mere sound and absent such definition. Unlike numbers, they may have some existence in the absence of things. This is important to keep in mind when parceling out different linguistic disciplines as phonics and semantics. Phonics deals with the concept of surrounding letters of words, enabling the language itself, known to be a left hemispheric domain, whereas semantics, addressing the meaning of what defines often multiple levels of inference, is the purview of the right hemisphere. The former area is a good measure of color coding, whereas the latter may be best utilized through customized sound and image translation software.